Hello, this is a short video on igneous rock textures. The image at the upper left of the slide, this is an aphanitic texture. When you're talking about textures with igneous rocks, you're really looking at the appearance of the rock and not necessarily how it feels. Okay, so when you see this texture, aphanitic texture, it means that the minerals are too small to see, so they are invisible. Usually when a rock has an aphanitic texture, it has one color, solid color, like you see here, gray in this instance. The texture of the rock adjacent to the right of the aphanitic texture is glassy, pretty self-explanatory, reflective. A lot of conchoidal fracturing can occur with igneous rocks with a glassy texture, particularly obsidian, which you see here, very sharp edges, conchoidal fracturing. Below the aphanitic texture and the glassy texture, we have two examples of pyroclastic texture. Unfortunately, pyroclastic texture is kind of hard to see in an online lab exercise, particularly if it is ashy, like you see here in this image. It's very hard to see the looseness and the earthy texture of the rock sample. Another type of pyroclastic texture is when you have a streak pattern, and you can see that here. I'll take these off. You can see you have some black streaks that go across the mostly red portion of this igneous rock. So this is also pyroclastic. The last two images on the bottom of the slide are vesicular texture. Vesicular texture is a result of cooling molten rock at the surface. The gases escape and those openings are preserved. In some instances, you have more of a smattering of vesicles like you see on the right side. And in other instances, it is highly vesicular like you see on the left or on the right sample there. So these textures, aphanitic, glassy, pyroclastic, vesicular, all indicate rapid cooling. And rapid cooling is an extrusive feature of igneous rock, so cooling at or near the surface. And these are related to volcanism, volcanic activity. And when you're talking about molten rock at the surface, you're talking about lava. We go on to the next slide here. The sample at the top, this is a really classic example of phaneritic texture. Phaneritic texture, the minerals are visible and they're roughly the same size. And so you need slow cooling for minerals to form. And they mostly would form at intrusive below the surface. And these features are referred to as plutons or plutonic igneous activity. And when you're talking about molten rock at depth, you're talking about magma. So we have extrusive features, we have intrusive features, rapid cooling, slow cooling. So obviously we're going to have a texture that has both. And this is a porphyritic texture. Porphyritic texture, you have large minerals embedded in a fine-grained matrix. The large minerals are called phenocrysts, and the background is a ground mass. So here you have two different rates of cooling. So it's intrusive and extrusive. The phenocrysts indicate the slow cooling process as the rock was cooling. So this would be magma. The ground mass refers to rapid cooling, and this is associated with an eruption, eruptive style of activity, magma surging to the surface. And you would see a lot of nasty volcanoes, your composite volcanoes, your St. Helens type. So in this cross section that we have here, excuse me, we have a cross-section of igneous activity. So this is where we would locate phaneritic texture, cooling at depth. The image on the upper left, this is an aphanitic texture. So we would expect to see this on the surface, lava flow. Obsidian indicates a very, very intense situation where magma either encounters water or very, very cold, quenching type of medium, like really, really cold air. The pyroclastic textures that you see on the right side would be the result of ash blown into the atmosphere. And on the left, we have this porphyritic texture, and initially it forms at depth, and then it comes to the surface. I hope this helps you out in understanding a little bit more of igneous texture. Thank you.